the absolute value of a number. Thanks for watching this video, and before working through this video, don't forget to like, subscribe to the channel and activate the notifications. It is very important to the continuity of this channel. The absolute value of a number is its distance from zero on the number line. Since distance is always positive or zero, the absolute value of a number is always non-negative. In other words, absolute value means how far a number is from zero. Let's get started by looking at the number line. The absolute value of a number is its distance from zero. For example, the absolute value of 6 is 6. This seems kind of obvious. Of course, the distance from 0 to 6 is 6, because 6 is 6 units to the right of 0. Where absolute value gets interesting is with negative numbers. How far is minus 6 from 0? The absolute value of minus 6 is also 6, because minus 6 is 6 units to the left of 0. 6 and minus 6 are the same distance from 0, so they have the same absolute value. The symbol for absolute value is a vertical bar on each side of the number. To show we want the absolute value, we can write in this way, which is read as the absolute value of 6 is 6, as the absolute value of minus 6 is 6. Algebraically, the absolute value of a number can be defined piecewise as follows. The absolute value of x is x if x is positive or 0. The absolute value of x is the opposite of x if x is negative. One never knows the value which may replace the variable x, as it could be positive or it could be negative. And the algebraic definition takes into account the fact that the number x could be either positive or 0 or negative. Let's examine the definition carefully. The first part of the definition tells us that if the number enclosed in the absolute value bars is a non-negative number, the absolute value of the number is the number itself. Look at item A. The number enclosed within the absolute value bars is a positive number, so the first part of the definition applies. This part says that the absolute value of 3 is 3 itself. The second part of the definition tells us that if the number enclosed within the absolute value bars is a negative number, the absolute value of the number is the opposite of the number. The opposite of a negative number is a positive number. In other words, because minus x is the opposite of x, minus x is positive when x is negative. Look at item B. The number enclosed within the absolute value bars is a negative number, so the second part of the definition applies. This part says that the absolute value of minus 3 is the opposite of minus 3. The minus sign flips the number back to positive. Look at item C. We first need to handle the absolute value part. The number enclosed within the absolute value bars is a negative number, and the absolute value of minus 5 is the opposite of minus 5. The minus sign flips the number back to positive. But in this case, we have a minus sign in front of the absolute value bars. We have to take into account the minus sign and follow the order of operations. We will get a negative number for our answer. Look at item D. Begin inside the absolute value symbols, just as with parentheses. Evaluating what is inside, we get minus 4. And as the final result is negative, change its sign to make it positive and drop the bars. Look at item E. Absolute value bars act like parentheses. we should do the operations inside them first. For each expression, follow the order of operations. Evaluating what is inside in the first absolute value symbol, we get 12. And as the result is positive, we may drop the bars without making any changes. Evaluating what is inside in the second absolute value symbol, we get -6. And as the result is negative, change its sign to make it positive and drop the bars. 12 minus 6 is 6. Absolute value as distance between two numbers. We know that the absolute value of x is its distance from 0 on the real number line. We can think of the absolute value of x as the distance of x from 0 and write this as follows. The absolute value of x minus 0 is the distance between x and 0. Another example. The absolute value of 5 minus 3 is the distance between 5 and 3, and the distance between 5 and 3 is 2 units. In other words, 3 and 5 are a distance of 2 units apart. Another example. The absolute value of 3 minus 5 is the distance between 3 and 5. And the distance between 3 and 5 is 2 units. In other words, 5 and 3 are a distance of 2 units apart. This makes sense because the distance is the same whether we are going from 3 to 5 or from 5 to 3. We can see that absolute value provides a convenient way to talk about the distance between any two real numbers, because distance, and therefore absolute value, is always a positive number. From these examples, we make the following definition. If x and y are real numbers, then the distance between the points x and y on the real line is the distance between x and y is just the difference between them, and it doesn't matter whether we go from left to right or from right to left. The distance is always the same positive number. That is, to find the distance between any two real numbers, subtract them in any other order. Take the absolute value of the result. Find the distance between the numbers minus 3 and 2. To find the distance between minus 3 and 2, we subtract them in any order because the absolute value will always be the same. The distance is 5 units. We can check this calculation geometrically, as shown below. Find the distance between the numbers 4 and minus 5. To find the distance between 4 and minus 5, we subtract them in any order. The distance is 9 units. We can check this calculation geometrically as shown below. Absolute value equations. An absolute value equation is an equation that contains an absolute value expression, and to solve it, we use the algebraic definition of absolute value as follows. If the absolute value of x equals a, then x equals a or x equals minus a. When solving absolute value equations, think back to our first introduction to absolute value and the number line. We know that the absolute value of a number is its distance from 0 on the number line. If the absolute value of x is a, so a can be positive or negative. Solve each of the following. We start with a very simple equation. The absolute value of x is 4. We know that x may be either 4 or minus 4. Since both are 4 units from the origin. Look at item B. To solve an absolute value equation, we begin by splitting it into two separate equations without absolute value bars, and then solving them separately. If the absolute value of x minus 5 is 1, so x minus 5 is 1 or x minus 5 is minus 1. The solutions are 6 or 4. On the number line, these values are each 1 unit away from 5. Look at item C. We begin as the previous example. We split the equation into two new equations. But in this equation, there is an algebraic expression on the right. And when that happens, we have to be careful and check the solutions, because the solutions of these equations may not be solutions of the original equation. Let's solve each equation separately to get two solutions. These equations are easy to solve. We now need to check our solutions. We will do this by plugging them back into the original equation. Pay attention. When we substitute minus 3 for x in the original equation that contained the absolute value expression, we can see that this value leads to a not true statement, while 1 leads us to a true statement. Therefore, the solution is x equals minus 1. Look at item D. First, we isolate the absolute value expression to one side of the equal sign. But now we should notice the absolute value equals a negative number. This is impossible with absolute value. When this occurs, we say there is no solution or empty set. In other words, if the absolute value equation is equal to a negative number, the answer is no solution.